Hello, everybody. Definitely need a new way to start these videos. I was gonna go with "Hey, cool cats and kittens," but I don't think I have it in me to do it seriously. So here we go. All right. So we have looked at simplifying radicals, looked at kind of adding and subtracting radicals, multiplying radicals. Now we're going to take it a step further and look at dividing and rationalizing radicals. So division of radicals works the same way as multiplication, which means that we are going to be taking the coefficients and dividing them by each other, and then taking the radicands and dividing them by each other. Once we have done that, we would take our final answer and make sure that it is in reduced form. So just to highlight that there for you. And then reduced form. So looking at this question, 36 root 15 divided by 9 root 3. So my indexes are the same. That's really the main criteria for me to be able to start dividing here. So I'll take my coefficients and divide them by each other. So 36 divided by 9 is 4. And 15 divided by 3 is 5. And that still has to stay underneath the root sign. If I look at that, it's as simplified as it can get. So that should be my final answer. And to ensure it's simplified, right, we're looking at the radicand and seeing, like, can I remove a perfect number from the index? So I can't remove a 4 evenly, and then I get bigger than 5, so there's nothing I could remove. Remember, you can always verify these on your calculator. So I could take the original question, which is, so brackets around your numerator, depending on like what your calculator looks like. So 36 root 15, close that bracket, the brackets around the numerator, and then brackets around my denominator. So, and then it's 9 root 3, close that. And so I get 8.944, and my final answer was 4 times square root of 5, which should give me the same irrationally trailing decimal, and it does. So that means that I've simplified correctly. All right. Maybe take a second, pause, try B on your own. And then I'm just going to continue here. So here I would go 28 divided by 2, which is 14. And then 150 divided by 3, which is 50, and that's going to go underneath my root sign. Okay, that's not my final answer, however, because that radicand of 50 can still be simplified. I know that 25 times 2 can break up into the square root of 50. So when I take the square root of 25, I get 5 times the root 2. So I kind of like skip a few steps there in my head, right? Technically, it's a square root of 25 times the square root of 2. So that's how I get the 5 root 2. And that all needs to still be combined by 15. So I combine those coefficients out front by multiplying. So 14 times 5 is 70. And root 2 is as simplified as that radicand can get. If I'm like, don't know if I did that right, put this in on your calculator, put this in on your calculator, and you should get the exact same decimal. And I think it works out to be about 98.9, blah, 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 some irrational number. Next one kind of works the same way. Now I have a binomial, or two terms being divided by a single radical. And really, I can just split this up, because each term here can be divided by the bottom. Same way if I had a polynomial, right? If I had like 4x cubed plus, I don't know, 12x squared, I could technically divide that all by 4x, right? So it works the same way when it's a radical. So I'll do this one term at a time. So 20 divided by 2 is 10, and 15 divided by 5 is the square root of 3. Now I'll go to my next term. So 14 divided by 2 is, or negative 14, I guess, divided by 2 is negative 7. And then root 10 divided by root 5 is going to give me the square root of 2. Now I'd want to simplify this if I could, but I'd have to now remember the rules for adding and subtracting radicals, which means you have to have the same index, so that's good, but the same radicand, which isn't the same here. So really, that's as simplified as that answer is going to get. And if I want to type this whole thing on my calculator and this whole thing on my calculator, I should get the same decimal, which works out to be about 7.4. So that's dividing radicals, except for we kind of have to go a little bit further. If we get to something like this, let's say they said, take 7 divided by the square root of 5. Can't really do that. And so what we have to do in these type of cases is we have to do what's called rationalizing the denominator. And rationalizing the denominator means we don't want like an ugly, irrational number on the denominator. And so we have to get rid of it. My final answer, always from here on out, should never have a root sign, so a radical, as the denominator. So we need to rationalize it. Whole numbers are okay, but not a radical. I can also have a radical on the numerator, but not on the denominator. So to rationalize the denominator, if I have just a single term on the denominator, like I do in all these examples, all I need to do is multiply by that exact number, right? So if I take this and I times this by the square root of 5, because this is something I want to remain in equality, whatever I do to the numerator or denominator, I have to also do to the numerator. So I'll times this by the square root of 5 over the square root of 5. Haven't done anything really. I just multiplied them both by the exact same number. So 7 times root 5 is 7 root 5. And root 5 times root 5 ends up being the square root of 25. So when I simplify that further, well, the numerator 7 root 5 just stays as is. But the square root of 25 is 5. So I have successfully what we would call rationalize the denominator. And that answer cannot be simplified any further. And so let's just go verify on our calculator that that does actually work. So I started off with 7 divided by the square root of 5, which gives me 3.13, blah, blah, blah. And when I rationalized the denominator, I had 7, the square root of 5, divided, oops, I gotta get that out of that bracket, divided by 5, which should give me the same number. And so that means, I have these two same numbers here, means I have rationalized my denominator correctly. All right. Let's take a look at B. Oops, did not mean to do that. Sorry. So 5 over 3 square root 11. So I want to rationalize the denominator. Now, it doesn't matter if I take the whole denominator. Really what I'm trying to do is just get rid of the root sign. So if I take this right now and times it by the square root of 11, that's what I want to do. I don't need to include the 3 there because the 3 is not an irrational number. Only root 11 is. So in order to get rid of the square root of 11, I need to times it by itself because 11 times 11 becomes a perfect square of 121. I can take the square root of that and it gives me 11. So what I do to the numerator, I'll also do to the denominator or vice versa. So 5 times root 11 gives me 5 root 11 over 3 times root 11, which is the square root of 121. So the numerator, 5 root 11, can't be simplified any further because 11 can't be broken into any perfect squares or perfect numbers of the index. And this is 3 times the square root of 121, which is just 11. So my final answer is 5 root 11 over 33. And I know that I've successfully rationalized the denominator, at least that far, because I don't have a radical anymore on the denominator, so that's good. And if I wanted to verify that they were numerically equivalent, I could take my final answer and my original answer, put them on my calculator, and I should get the same numerical value. Make sure you're using brackets when you do that, especially if you have an older calculator. I want you to try C on your own. Even though it has a variable in it, the question works exactly the same way. So pause the video, take a second, try that on your own. So hopefully you've had a chance to, or you paused the video and did that question. If you originally look at this, hopefully you can recognize, like, I can actually simplify this right here. The square root of 25 is just 5, right? So this is really 9 times 5 over the square root of 6x, which if I want to keep simplifying is 9 times 5 is 45 over the square root of 6x. Now, whether you do that now or you did it at the end, you should get the same answer. So what I would have to do now is I need to rationalize my denominator. So I need to get rid of the root sign on the denominator. So I'm going to times by whatever's included in that root sign. So times by root 6x to the denominator. And what do I do to the denominator? I have to also do to the top. So multiplying here, 45 times 6x just becomes 45 root 6x. And root 6x times root 6x would give me 36x squared. So really that just gets rid of the root signs when I multiply by each other. And then I would have to see if I can simplify any further. I actually think that I can simplify here. If you left it here, that's okay. I haven't got into an example that you could do this with. But what I notice here is both 45 and 6 can be divisible by 3. So if the coefficients here can be simplified, I want to do that. 45 divided by 6 is 15 square root 6x over 6 divided by 3 is 2x. Now I can't simplify any further. Remember, you can't simplify this with anything because it would have to be simplified with another radical, which we have rationalized, so there shouldn't be anything down there. So that's my final answer, as simplified as possible. If you left it here, that's okay. The thing to recognize is that one in red is just a more simplified form. So if you're like looking on a multiple choice question, A, B, C, D, that's not going to be there. Okay, so 5 over 8 cube root x. So this example is actually a little bit different, but let's kind of solve it with the same strategy we've been using thus far. So I want to rationalize the denominator, which means I need to take this and multiply it by whatever radical I have. So I'm going to take this and times it by the cube root of x. And what I do to the top, or the bottom, I'll do to the top to preserve equality. So this becomes 5 times the cube root of x over 8 times the cube root of x squared. Now, when I do that, I actually didn't get rid of this, right? Because the cube root of x squared, I can't simplify that any further. So what I need to do is do that twice when it's a cube root. Okay, so up here on the numerator, 5 times the cube root of x times the cube root of x is going to give me 5 cube root of x squared. The bottom is going to give me 8 times the cube root of x times the cube root of x times the cube root of x, so cube root of x cubed, which then simplified becomes the numerator. I can't simplify any further, so it stays the same. Over 8, well, the cube root of x cubed is just 8x. So when you are trying to rationalize a cube root, you actually have to multiply by whatever that radical is twice, not just once. If it was to the 4th root, you'd have to multiply by that number 3 times rather than once or twice. So, okay, so there is kind of the basic form of dividing and rationalizing exponents. So I would suggest you go take a look at the homework number 3. And just take a look at some of the basic questions on like the first page, which is number 1, just like questions A to K. Okay, you don't have to do all of them, do about 5 or 6. And if you're getting the right answer, that's great. Go watch the second part of this video. All right, thank you.